Hello guys, so we made another one in another video in the instruction of how to you are in doing all the forecasting analysis. So the today's session, I first of all talk about the simple forecasting method. So basically we sometimes we think about very advanced method that we going to study later, like for the regression, multiple regression for the time series or the exponential smoothing, or sometimes even like RMR model or the neural networking. They all could be something you view is very like fantastic, right? And you think like that could be something very worth. But however, sometimes you have to think it back, like the most simple, the simplest will be the better. So sometimes even when you run it very good with the very fancy and advanced model, it doesn't mean that it's be necessarily better than the very simple method. Actually, when I say that, I mean that mean like normally the advanced method could be better, but however sometimes not, and we normally use for the simple forecasting methods like a benchmark. So we compare the new methods like a benchmark to check whether it should be better than this kinds of simple method. And you think like in a way it's like, oh, they even worse than the very simple methods like the average methods or the naive methods. They not work to do, right? So we use them to just compare to the performance of the advanced method. And some of the thing we going to introduce today will be, first of all, the average method. That could be the forecasting use all the you just forecast all the future values based on the average of all the historical value, and I show you it later. Or you use the naive method. That means you use the latest observation of the historical data, and you just assume that could happen again and again and repeat in the futures. So you assume all the future value equal to the last previous observation. And we also have the seasonal naive method that could be also used for the last observed values, but from the same season of the years. So for example, you use the same data of the last year in all the data of the sale or revenue in the like last December of the 2020, right? For the predicting of all the December of 2021, 2023, 223 for all the December sales. So that's the way. And the trip methods, actually they just the same with the naive method, but we plot for the average chain, and we can see it in this one. So I'm going to use for some kinds of them, including for the average method, the naive method, the seasonal naive, and the trip. So we going to do it and just conduct it right after now. Okay, so come back with the R script and the R Studio interface, and I hope that now you already has learned how to do it and get familiar with that over time, right? After like 2 class, and we first of all try to remember just libraries, and we call out for the FBP2 packet, all right, and then we call out, and then we go associated with them what the ggplot2 for the data visualization, and the forecast packet for forecasting. Okay, and this could be the practice for the 3.1. that would be what people call the simple forecasting method, right? Okay, now let's go and check it. So first of all, I want to choose here the data Australia beer. Okay, the data Australia beer, that could be the data about the quarterly Australian beer production. Yep. So this has been just spread out in all the beer production in Australia in the mega liters. I guess a million liters from 1996 quarter 1 into the quarter 2 of the 2010. Okay, so this will be a quarterly data. Okay, and let's go and check it for some of them. Like we want to see how will be the very first, some few of the first. observation. So we have, according to this, that's true from the Q1 of the 1956, and this will be 284 megaliters. Okay, and I want to check for the last one. So the tail, you use the function tail to see the few last observation. Normally they will default select 6 different last observation. Okay. Oh, I'm sorry. Yeah, I've got it wrong. Okay, then the same. So the last observation was in the Q2 of the 2010, and that's going to be 374. Yeah, 374 data in the megaliters. Okay, I want to check it for the auto plot a little bit. Okay, so you might be very familiar with this function after the last week. Okay, and I just want to check it to see, yeah, this look like this. It looked like the data had a seasonality pattern. They change over year, right? And that makes sense with the beer production data, right? They make it more in some several time of the year, in some season of the year, while they reduce for the production in several time of the year. So they make sense, and it looked like the trend uptrend. That's the uptrend, right? From the 1956 into around like 1975 something. So they stop it here and then they fluctuate. So it looked like they have an exponential increase in the very first few years. But later, from the 1975 until like 2010, it's quite stable, and sometimes they drop it out. So let's go and check it and see like how it look like. Of course, like I can use this for later function, but I will just quickly introduce for you for some kinds of the data. And we first of all talk about the average. Okay. Oh, what happened with the average method? Okay. And the average method, for the average method, we will use the function. So I will use the pi. Okay, one more time, remember about that. I will use the tidyverse library. Okay, and I want to use the tidyverse. Okay, packet. So I want you to, for the pi function, you want to go with all for the operation of pi. So it's safer for the time. A US beer and the pi. And then I wanted to use for the mean app. That means mean forecast. Okay, and I wanted to use for the x equal to 12. That means I wanted to forecast for the next 12 months. 12 quarter. That's equal to 3 years, right? I going to forecast for the data of the next 12 quarter. Okay, that's equal to 3 years. Okay, let's go and check it. And you can see over here, we have the low 80%, high 80%, low and high 95%. That's going to be what people call the prediction interval for the future. But like we will talk about that later in the later of the chapters. Like maybe in the section 3.5 for the prediction interval. Let's just stop not talking about that. We just focus on the point forecasting over here now. And you can see like over here, they use the same, they have the same value for the forecasting of the future, even for the next 12 quarter, but they have the same value, right? That's simple because they just take the mean value of all the historical data. If you take a look like for the historical data of the AUS beer, so they will be the same, right? They will be the same, and they take the average of all of them to do like that. Okay, now so you see that there's this way. That should be the average method, and let's go and check for another one. That should be the naive method. Okay, so for the naive method, we will go and do it with the naive. I will use the same with the beer. I'll use beer, and then I do it with the naive. Okay, function and x equal to 12, and you're going to see now remember about the last one when I talked about the details of the data, remember? So the last observation of the data were in the Q2 of the 2010, and that will be 374 megaliters. So they use it for the naive methods, and they keep use the same with the 374 of the Q2 2010, and they use it for the future forecast for all the data later. So they're quite simple and easy to understand, right? Okay. And now, actually, like sometimes the naive method, you can use it the same with the random walk method. They're the same, and you can also use for the same result. Okay, if you put it like in the same, and you put in like random walk forecast. Okay, s equal to 12. Okay, and let's go and check if they are different or not. No, they are the same, right? You're going to see that they are the same with all the data between the naive method and the random walk method. So let's talk about another one. So for the seasonal naive method, okay. So seasonal naive method, they will choose their data from the same season of the last year to get the same with the naive method, but they will use the same data of the same season of the last year for the forecasting of the same season in the next year. So we're gonna see like let's check it. Okay, so as naive, so AUS year. Okay, let's go and check it with the as naive. Okay, and x equal to 12. Okay, and you can see it what happened over here. Let's check it with the one more time the details of the AUS beer. Okay, and you see like what they do for here. So they use the prediction for the quarter number 3 of the 2010, of the 2011 and 2012, even for the 2013. No, not the 13, just 12. Okay, because this will be the quarter 3. So 3 of them, they are all the 414, and they are equal to the quarter 3 of the 2019. So you see what the point here, okay? They still the same. They use the quarter 3 2019 data to predict for the quarter 3 of the next year. Okay. All right. Let's just do it, and the same they apply for the quarter 4, quarter 1, and quarter 2. Okay, so the quarter is easy to understand, right? The last section, the last contents of the methods will be the drip method. Okay. The drip method. Okay. So they're equal to a random walk with a drip. Okay, a drip that means they will still use the naive method, but however they adjust it by the chain over time. So they have the function about how to calculate for the chain in average over time of the data, and they just add it into the data of the naive method, but however they increase over time a little bit. So they will be a kind of linear function to just measure for the future data, and we're going to do it. So in this case, we don't have the drip method function. They just integrated with the random forecasting method. All right, random walk forecasting method, but I will use this for the AUS beer. Okay, and then I use the random walk forecast. Okay, and x equal to 12, the same. However, here when I talk about the drip, I can put them with the true. So that means still the random walk forecast, but they use the drip here. And you can see over here they will be a little bit changed. They still, for the first one, they use for the same with the 374, but then they add for about 0.4147, and the second one, that will be 374, but plus for 2 times of the 4147, and they do it the same. This will be the like 3 times, 4 times of the 14.7. That should be the average increase over the historical data, and they apply them for the same philosophy for the 12 quarter. You got it? Okay. Now let's go and do it with the graph, and we're gonna see like how we compare between the performance of different kinds of method. Because of the data of the Australia, the data is quite long, so I want to subset the data from the quarter 1 of the 1992 to the quarter 4 of the 2007. Okay, and how can I gonna do it? I will call them the beer 2. Okay, and I say it with the a US beer and pi function and the window function. Okay, I have to clarify about the start date. So the start, I can clearly say it is 1992 from the quarter 1, and with the C of the, okay, and we clarify this will be 2007 with the quarter number 4. Okay, and let's go and check it. So I want to see head of the beer 2. I just want to check it for sure. Okay, that should be from quarter 1 2019, and I want to see the tail. Oh, sorry. Okay, and I want to see the tail of the beer 2. Okay, the same. Okay, and now we have the last data of the quarter number 4 of 2007, so that's correct. And let's go and do it for, we're going to plot the time series and compare different simple method of forecasting. Okay, let's go and check it. Sorry. Okay, let's go and check it. And first of all, I want to use the auto plot function with the beer 2. Okay, so beer 2, I want to just put them into the auto plot function first. And you see that's over here, that's much better than the previous one, right? Because the previous one, they just scrap down into the too long, and we see the different pattern. But however, when we jump into the time series of the smaller window, we will be getting more stable. However, I'm not feel it's okay here, because this will be just the data without the forecasting. So I want to add another layer, so I can see like how the performance of the forecasting method would be. So I say the auto layer, that will be help me to add for another layer for the graph. So I use the mean function. Okay, the mean function, and I say beer 2 one more time. Okay, maybe I will not use. No, I will not use this. Of course, this is not so. Beer 2 one more time. Okay, beer 2, and I do it. And I'm going to use this for beer 2 and the mean forecasting, right? X equal to 11. So I will forecast for 11, just like quarter ahead, and I'm going to use it for the auto layer. Okay, the auto layer, but now that will be I would say the series. Okay, series, I will call it equal to mean. Okay, and I will say the PI that mean the I will put it like 4, that means the prediction interval that is equal to 4, and we're going to check like what it look like. Okay, you can see over here, right? This could be the methods of the mean values, and they will be the equal to the average of all the data. And they do the same for that. They had the series name, and this would be mean. Okay. Yeah. So we have the prediction for the next 11 quarter, and I will one more time just explain what happened here. So if I clarify is equal true, you can see how they're different. This could be the prediction interval of the mean values, and they will gonna go on like this way. But however, if I do that, I will just lost for all the meaning of the prediction benchmarking. I mean, I want to compare for the different method, right? If I use for the same like bit prediction interval like that, they will overlap on each other, and it's very hard to see and visualize them. So that's the reason why. Okay. I will go in and continue and apply for the different kinds of method. Now I copy from my code, and now I will not just use the mean function, but I will use the naive function. Okay. And I will say it could be naive. Okay. Okay. Of course, here I will have to plot it. Don't forget about that. Okay, do it, and it look like now this will be naive function. You see, like they equal to the last observation. All right. Now one more time, but I use it. It's not for the naive. This could be now for the season naive. Okay, function auto plot, and I even do it with the seasonal naive. Okay. Alright, and I do it with this one more time. Okay. Okay, and you see it over here. There's something missing. I don't know why. Mapping equal to and our random force, and they look like they are. Oh, sorry. Yeah, this is the reason why. I'm sorry. Okay. Yeah, I got here. Yeah, and now this will be the seasonal naive function. We can see over here they are gonna different to each other, and we now very hard to say like what would be better a bit. According to me, I feel like the seasonal naive will be a little bit better than the mean values or the naive value, right? I use the last one. I want to check it if that's really gonna work in. So I use the random walk. This means with the trip. Okay, so I say trip equal true and trip method. Okay. Oh no, one more time. I forgot about this. Okay. Let's check it. Yep, that should be it. The trip method from the name, but they increase over time. Alright, this will be very good for you to start for your data, right? And you're gonna check it. Your work will be like you have to compare it for the other kinds of stuff. You can brought this is with the according to the book, the Google 200. Okay, the Google 200. I want to check it. 200 data, and you're gonna check it. So daily stock, closing the stock price of the Google Inch. They collect the data between the February 25, 2013 into the February of the 13, 2017 with the actual split. So that's will be the day, the daily, the daytime, the daily core data. Okay, yeah, that will be your work to just brought this at home. I go and come back with this my graph, and I gonna just ask for another layer of the data, so I make it like more productive and more clear. Remember of GG title, I want to have the title for my forecasting draft, so I want to forecast. Okay, I will say that forecast for quarterly. Okay, beer production of Australia. Okay, let's go and see it. Okay, they now have this. Alright, but I'm not feel satisfied with that. I want to have the X level the X level here, there should be year, right? I put it year, and I want to have the Y level too. So Y level, that should be like mega liter. Okay, that should be like mega liter. Okay. Alright, let's go and check it. Yep, they look much better now. And the last one, this should be a little bit new, which we use the function guy. Okay, we'll use the function guy, and this will be a new function. And if you feel like uncomfortable with that, you can ask for the help, and they will have to clarify about what we're gonna do. So guy for the its scale can be set for the scale by scale with the guy argument, and that's how to just create for the right over here. I want to use this for just to make the scale column. For example, here I want to use guy and put for the color of the guy of the legend, because that remember about my graph, remember my plot. So all the series here, I want to put them into the I want to change it, not the series, but I want to change for the name of the level of the legend, right? So guy over here, I want to have the color, okay, and I will set them equal to the guy and sky and legend. All right, and I want to have the title of the legend equal to the new one, forecasting method. Okay, now let's go and check it. Yep, the function now, and I zoom it out. You can see like they should be, everything has been available here for 4 different methods, and I change for the title of the legend will be forecasting method, and I compare between the trip, the mean, the name, and the season name. Okay, right. Hello. And in this part, we will talk about the transformation and the adjustment of the time series. So, when we talk about the different the pattern of the historical data, this can be seasonalities. They can be have some errors. They can be have some kinds of pattern like the trend, right, and the cyclical. So they make the data would have more variation, and they make the data more like difficult and complicated to do the forecasting, and that's the reason why the people want to just simplify all the pattern like that to produce more the accurate forecasting. Remember, the more like consistent and the less complicated of the historical data, the better forecasting that can be generated with the higher accuracies. So they want to remove further source of the variation and making the pattern more consistent across the whole data sets. Over here, we first of all talk about the 3 first method about the calendar adjustment, the population adjustment, and inflation adjustment. Basically, we will most talk about in this example will be the calendar adjustment. Because of the calendar of each month, maybe, right, they have the different number of the day. So some month like on the February, they just have a 28 or 29 day. For other day, month of the year, right, and like for January, like on March, they have up to 31 day. While in the rest of the year, they just have like 30 day. So with the different number of the day in a year, so they will have the kind of like the different, like for example the total sale, right, the sale of their year, like for a month, that could be look like in February they will be less than on the January, because at January we have up to 31 day for sale, but for February just have a 28 day, for example. So that could be the reason why they want to do for the calendar adjustment by dividing for the values of all the like monthly data for the number of the days. So that's have to just have the average daily data. And the same thing we do with the population adjustment by use the total value and divide for the per capita data by divide for the number of the capita, divide the number of the population. Inflation adjustment, they do it for using the CPI for adjust for the values of the monies. They will be more like relevant in the economic class or in the finance class, but this will be one of the way for people to adjust for their time series of their monies, time values of the money, so they increase or decrease over time, right? And lastly, they can do for the mathematical transformation. We can use some of them like the logarithm transformation or the power transformation. The box-cut transformation will be what we're going to do in this right here. But however, understand that the transformation by the mathematical function, we can have to just ease and smooth and make all the data of the time series become more consistent. Okay, so for example, over here we can see like how the data of the first data sets, the one they have a chain over time, where they have the seasonalities, they have the trend up, but however they're not consistent. You can see like the seasonalities, they become larger over the higher level of the values of the data because of the uptrend, right? But when we use the cube growth transformation, so the data becomes smoother. Okay, they still increase, but like the fluctuation and the variation of the data of the seasonality, they become smoother and quite stable over time. And the same thing happened with this data, right? In this we opposite side, when they increase for the data over time, but however you can see like the variation just reduce over time and they're not consistent, and they want to use it for the log electronic production. They do it for the logarithm, and they have to just ease all the variation. So we talk about the box-cut transformation by the logarithm and another function. For this, they have to just calculate for the lambda. That should be a kind of like constant used for the transformation in this function. But however, we talk about that later, right? And we're going to do it. So step by step, I will show you how to do it all. Okay, so let's come back to the practice on the practice section 2.3.2 for the transformation and adjustment. Okay, let's go and check it for the first of all, the data of milk. Okay, so the data of milk will be the monthly milk production per cows. That's average monthly milk production per cow over the 14 years in the Australia from January of the 1962 into December of the 1975. Alright, and let's go and check it for how it looked like for the some very first data. They had data, yeah, they had the data of the January into June. This is first month of the 1962, and we see like the end of the milk data. Okay, and we have the same. Okay, it end in the December of 1975. Okay, now let's go and just do it for let's see it like how normally for the auto plot. Let's just play with it, okay, a little bit with the milk data and see how it look like. Yeah, this could be the data, and it look like there's some variant in the data. So some of the month, okay, some of the month they look like they larger than the other, and we have the same with this could be the different in month. Okay, so I wanted you for the transformation in the calendar transformation and how I'm gonna do it. So I'm going to just try to make a data called the monthly data. Okay, the monthly data, and they will be just equal to the milk data. Okay, they the same with the one because I remember about, oh sorry, this will be monthly. That's okay. So the monthly data, they will be the data of the just milk only for the same with the original data. And I wanna have another data called let's think the daily average. Okay, the daily average. And yeah, I will just follow for the order of the book, and I will use it for the milk data, but I divide it for the month day, okay, of the milk data. So they will for the Monday of the milk of the data. Okay, if you don't really know what exactly the Monday of the data of the milk, okay, you can see like what will be the day number of the day in each month of the data. So like for January they have a 31 day, February they have a 28 day, some years they have the leap years like 1964 they have up to 29 day, but however they basically they provide for the information about the number of the average day of the data. Okay, so for this way we measure for the monthly, like the daily average data for each month in the milk time series. Okay, and with this I will find like a little bit hard for me to just generate for this one. So how can I gonna do it? First of all, I wanna create for data frame. Okay, I call it like df, the data frame, and I want to see combine. See combine mean that means the column combine of the milk data. Okay, so I want to say it the monthly, and another one could be the daily. Okay, average. And if you take a look into the head of the data frame right now, you can see like at the same time they just combine all the data in the month of the each year, and we have the comparison between the monthly data and the average daily data. Okay, and we gonna check it like we compare them in the same plot to see, right? Okay, we gonna compare the two time series on the same plot. Okay, and to see like how they look different now. Okay, and I'm going to use for the TF data, and I use the auto plot function. Okay, if I just stop like this, all the data look not so cool, right? Remember about what last time I told you about the last section of the chapter number 2 in the week 2 and 3. So if we put them in the same graph, they will look not so good because they have different in the units, right? For the monthly data, they should be about like from 500 to 500. But why the daily data there's about 20 something or 30? So it could be better here if I call this like faces. Okay, the faces must be, I would say they would be equal to true. Okay, and you see like now all the two times you separated, right? With the monthly data they have different units, the daily average they have different units, and it looks good now. Okay, that would be the function. And now as you can see over here, right, with the monthly data they have the different in the variation in the each month, but however for the like daily average they smoother, right? They look better and with less the variation. So that's will be what I'm gonna do. If I gonna put the data into the forecasting model, I will use the second one. Okay, and now auto plot and the faces does look good, and I want to just add for the X level. I want to see call it like year, right? Normally I would do it with year. If what I do, okay, and plus for the X level, I will put it like the power, okay, the power of the milk, right? Okay, and one more thing, I want to have the GG title. Okay, I want to have the title, that should be the milk production per cow. Okay, let's go and see it. Now let's be the point. You can see how they are being represented. We have the color X level, Y level, and compare between the two data. Okay, that's good. Now let's go talk about the box cost transformation, right? The box cost transformation could be a way familiar of the transformation method, and when we talk about that, we will gonna check it, and we'll talk about this one. Okay, we're gonna check about this one, and I want to reload for this one. Okay, I want to see it, and you can see like for the mathematical transformation, this will be the original data, I guess. This will be the original data. I don't know. Maybe it look like this. So when we have the different lambda, the transformation of the data will be change over time, and you see the pattern and also the seasonality and the variation. But we have to check for you and try to figure out the kind of suitable, the most kind of optimal lambda value to make sure the data and the variation will be stable over time. And this look not good, right? It's be larger with the variation in the beginning, but not good in the end of the time series. So we see and try it and move it, and it look like over here they have some improvement, but they still work like that. The same thing happen if I put it like over here for the lambda too big and close to 2. Too small variation in the beginning of the time series, while it's too large in the end of the time series. So the same thing happen if I reduce it. It has some kind of improvement, but that's not enough. I make it stronger, and stronger. Look now, it looks like I'm close enough. So with like lambda equal to 0.4, they look quite good, but however they still be like smaller in the beginning and bigger in the end. So one more time, I put it like 3. Look better now. 2. In this way, they one more time they will be quite stable. 1. Okay, it look like that should be better for me to choose between like 0.2 or 0.3, because the time series will be look very well like look this way. So the point would be like you will have to find it and figure it out for the what will be the best lambda value for all your time series. But however, in the R we can generate it very easy by some function, and they automatically for you to figure it out what will be the best cost box lambda for use. So let's do it, and we practice for the box cost mathematical transformation. Okay, and gonna check it like lambda. If you wanna do it and very easy to find for the lambda, you should use the function box cost, okay, lambda. So they will find figure for you for the function about what could be the best lambda for you. So over here, I wanna first of all just use for the elect data. Okay. Remember about this one, the electricity production from monthly data from the January of 1956 into the August of 1995, the monthly data, remember? Okay, and I want to check and try to see out what would be the best lambda as I use. Okay, and that should be 0.265. Alright, and this would be the best lambda, so I'm going to do it for that. I would just call them into the lambda, okay, best lambda or lambda, whatever. Okay, and I will next time I don't have to just put in like this much, but I just use for this function to call out for the lambda. And I'm going to just do for the auto plot, okay, or yeah, elect, remember, and then I will use for the box cost, okay, box cost, and I put in the function, the number will be lambda. Okay, this could be the point, this could be the transformation, but I don't want to see it. I want to see how it could be for the auto plot. Okay, and let's do it with the, okay, sorry. Yeah, so for this one, why I'm so stupid like this? Man, one more thing, I just have to put it like auto plot function, and let's do it. And now we can see all things like this way. Okay, Does look much better now, and all the data has been transformed with the optimal lambda equal to 2.256 something. Okay, right. You can add in whatever you want to say, like with the GC title, and GC title will be the electricity production transform data transform by Boxcox method. Okay. And for Y, just X level, that should be year. Okay, it's looked like this way. Okay, the last one that I want to talk about in this section, it will be the end of this everything, will be the bias adjustment. So the bias adjustment will be the difference between when we use the transformation like the Boxcox transformation or the logarithm transformation, right, they will make the data will be the new data that will be smoother with the pattern and the variation. However, remember, in the end of everything, we had to just back reverse this, right? We just back transform the data from the Boxcox transformation into the regular data. And we use, for this one, for example, if they use the logarithm, we will have to use the exponential to just transform them one more time. However, this will be the point. Normally, they use for the back transformation by the median. But however, we should use the mean value of the back transformation to just do it all. And they will make the difference between the mean and the median usually used for the back transformation forecast. And that's make a bias. So RStudio and especially for the FEB2, they use for the bias adjusted point forecasting with the bias adjusted function. So that's help us to just it's closer, and we transform it from the back transform forecast with the median values into the mean value, and that's help to improve for the transformation and the prediction values and accuracy. So alright, let's we use the bias, okay, adjustment for the time series data forecasting. Okay, and let's go and do it and see like how it different. So first of all, we're gonna just use it for the X. Okay, the X. Okay, X. So what is the active? That's the price. The X in Australia. That could be in the US from 19,000 into the 1993 for the constant of the dollar. So that's the time series data, and let's go and plot it. Okay, auto plot of the X. Okay, and this will be all the data from very like almost about 100 years, like yearly data. Okay, and now let's go and see it like how we can just do it and compare between the two back transform the method for clear. So first of all, with the X data, we use for the random walk forecast, right? Random walk forecast, that means the same with the naive values, but however we want to use for the trip. Okay, and I would say the trip methods will equal to true, okay, because I want to use for the trip. And the lambda, remember, how maybe I would just transform it like logarithm. So lambda equal to 0. If you're not clear, just go back into see the material of the book. Okay, and I want to focus about in the next few years, and the level of the kind of prediction interval will be 80%. Okay, and this will be the data. Okay, right. If in this case I'm going to do it, and I'm going to generate for the auto plot. Let's do it. and see how the data look like this one. Okay, and with the same method, but however now I change it. So this one, this will be the batch transformation. With median. Okay, so this will be the batch transformation with median. Why I use it for the batch transformation with the mean? Okay, so I use the bias adjusted. Okay, so they're the same, do the same with trip, lambda the same, and everything is the same except for one thing. So they automatically can generate for the adjusted function over here, and with this one I would just have to put in like bias adjusted. Okay, adjust equal to like I say true. Okay, and do it. Now you see the two functions are a little bit different now, right? With the mean, okay, with the mean, with the median, so they are become like larger and larger, and they more biased, and they pull now for really far away from the mean values. Why? If I use the kind like the bias adjust this, they will be closer with the mean. So with me, I would say this would be better. Okay, and that's be better for me now. We just generate them in the same one, and I will not just generate them separately, but I want to put them in the same one. So that's better for me to just adjust for this data into like this will be the forecasting one. Okay, the forecasting number 1, and this is forecasting number 2. Okay, right now they have the two different one. And I use the function as I will not just plot the two forecasting method in the same plot to compare. Okay, now let's do it. I will use the function auto plot. Okay, and act. So this will be the first layer of the data. Okay, and then I auto layer. I add for the second layer, and I use the function of the FC. So the result of the FC1 number 1. Okay, and then the same, I use the series. Now I want to put in the name of them will be the symbol back transformation, or the median transformation. Okay, look like this way. Okay, and then I put in another auto layer and the FC2, but it's the series name. Now I will put in like this way will be what we call the bias adjust. Okay, and with this one I want to see for the PI equal to false. Okay, I don't want to see for the prediction interval of this one. I just want to see the prediction interval of the two. If I clearly clarify about the function PI equal to true. Okay, so both of them will look like this. This will be the adjusted, with this will be the symbol, and this will be the adjusted bias of the forecasting when we do the batch transform. Yeah, and that will be the everything, and I can do whatever I say. Would be like one more time I want to use the guide function, and I want to just add in for the color. Okay, no, not this one. Color equal to the guide. Okay, legend. Okay, and title, I want to have the title. That should be different now with the forecasting method. Okay, look at this way. Okay, they change it, and sometimes I can change it also for the changing the I don't know what will be. I will have the /lab. Okay, that should be year. Okay, and then I want a GG title for the X-Bride. That's good. What we're gonna do. Okay, and this will be the thank you for a lot for just attending for this very long video. I want to just stop this one and we continue for another video about the instruction how to just conduct it with the third chapters of this one, the forecaster, the toolbox. Thank you a lot.